This chart is my AI getting worse because I gave it more data, same questions, bigger knowledge base, worse answers. And the only reason I know it happened is the thing this video is about. Evals. By the end, you'll know exactly what that word means. And you'll watch me poison my own AI's knowledge base on purpose and catch the damage, live with numbers. Because here's the thing, nobody really says out loud, you changed a prompt, you swapped a model. Is your AI better now or worse? For almost everyone building with AI, the honest answer is no idea. We eyeball two outputs and hit deploy. And look, I come from test automation, and even I shipped a dozen AI systems, agents, skills, an entire second brain with zero evals on any of them. In 2024, airline's chatbot told a grieving passenger he could claim a bereavement discount after his trip. The real policy said no. A tribunal made the airline pay. That bug wasn't caught in code review. It was caught by a judge. So let's fix it properly. What evals are, how to test your agents and your retrieval, which tools to use, and one experiment you can run on your own knowledge base tonight. Let's go. Dead simple, I promise. An eval is three things. You give your AI an input. You apply some logic to grade the output, and you get a verdict, pass or fail. 3 words you'll hear on repeat. First, a task, the input plus what counts as success. Then a grader, the logic that scores it, and a harness. That's the plumbing that runs all your tasks, records what happened, and adds up the score. If you've ever written an automated test, that's the same shape, arrange, act, assert. And an eval is just a test case, with one twist that changes everything. It's a test for a system that won't give you the same answer twice. Here's my favorite shortcut. If you write software tests, you already own most of this vocabulary. A test case is a task. An assertion is a grader. Your test runner is a harness. A snapshot test is a golden dataset. Your regression suite, regression evals. A flaky test, that's non-determinism, except here it's not a bug to hunt, it's the nature of the thing. Code review, a human judging quality, that's an LLM-as-a-judge. And the hardest one, testing theory literally has a name for it. The oracle problem. How do you know what the right answer even is? In evals, fuzzy oracles. And if you've never written a test, congratulations. You just learned the whole vocabulary in 40 seconds. But the analogy breaks in exactly 3 places. 1. Non-determinism. Same input. 2 runs, 2 answers. So a single green run means nothing. 2. There's usually no single correct output. Ask for a summary. There are 100 good ones. Exact. Match is the wrong shape. 3. Fuzzy oracles. For a question like, is this answer good? The truth itself is a judgment call. Keep those 3 in mind, because honestly, all the machinery in this video exists to beat them. And keep this in mind too. In a few minutes, I'm going to add documents to a knowledge base and make it measurably worse on camera. First, let me show you what an eval run actually looks like. So, use case 1. The skills you build. Everyone is shipping skills right now, and almost nobody is testing them. An engineer at Google DeepMind measured this. Skills bench indexed about 50,000 skills from GitHub, and the ones with evals, almost 0. Now, my own machine is full of skills, so I picked one, my nano banana image generation skill, the one that makes my thumbnails. I wrote 12 prompts for it, 5 that should fire it, 5 that should not, and 2 vague ones written like a real user. With the skill installed, it fires 86% of the time. Remove the skill, same prompts, 0, and it does not even fail loudly. The agent quietly starts hand-drawing SVG files instead, which honestly made me laugh. The negatives were mostly clean, 1 in 10 fired when it should not have. But the miss that genuinely surprised me was the vague one. I need a thumbnail for this video, make it pop. That one never fired, not once, while a sharper version of the same ask fired every single time. 1 notch vaguer, and the skill goes dark. Half of your skill failures are trigger failures. Then the twist, my first grader was wrong too. It matched patterns across the whole transcript, and the skill's own documentation echoed straight into it. My checks were passing on the skill's own docs. The score looked healthy, and it was fake. I fixed the grader, the number dropped, and that is the real lesson. Graders need evals too. One distinction worth keeping: capability skills are temporary. The eval tells you when the model catches up and you can retire them. Reference skills are durable, the eval protects them forever. And when you do retire a skill, keep its eval, because the test outlives the code. To be honest about the setup, one model, 2 tries per prompt on my machine. It is a sketch, not a benchmark. That is use case 1, the skills you build. Use case 2 is bigger, the knowledge your agent stands on. So this is the companion repo for this episode, Agentic Evals Lab, link below, and I'll tour it properly in a bit. Inside, there's a knowledge base for a fake store called Loomstead, product docs, refund policies, incident reports, and then a golden set, 50 questions. I froze in advance, tiered easy, hard, paraphrase, multi-doc, plus a few that are deliberately unanswerable, because I wanted to catch hallucination. One command, watch. It fires every question through 4 retrieval arms, plain keyword matching, BM25, the classic keyword ranker, vector search, and hybrid with a re-ranker, and scores each arm on 2 things. Did the right document show up? And how high did it rank? There's the scoreboard. Hybrid hit rate, 98%. And notice what did not happen. No API key, no LLM call, no waiting. This ran in seconds and it's free. That's an eval. 50 tests for a system that can't be trusted to answer the same way twice. Everything else in this video is about making numbers like bees trustworthy and then watching them catch something. If the output changes every run, passing once tells you nothing. You won 1 coin toss. So you run each case k times and report a rate. 2 rates and they mean opposite things. Pass at k, meaning at least 1. Try works. Right when a human picks the best result, like generating code and keeping the one that compiles. Pass to the k power, meaning every single try works. That's the reliability metric for anything unattended, your scheduled jobs, your bots, my second brain answering while I'm asleep. The number that genuinely got me comes from a benchmark called Tau Bench. The best agent solved about 60% of its retail domain tasks on 1 try, require 8 for 8, and it drops below 25%. Same agent, the scarce resource isn't peak performance, it's consistency. And a single green checkmark hides exactly that. 75% per run sounds fine, until you need 3 for 3, and you're at 42. So how do you grade a fuzzy output? Honestly, 3 ways, and I reach for the cheapest one that works. The bottom tier is code. The regex, is the JSON valid? Does it compile? Did the database row actually get created? It's fast, it's free, it's objective, and it runs on every change. You've seen this already. That scoreboard earlier was pure code. The middle tier is an LLM-as-a-judge, a model grading against a rubric. And the top tier is humans, the gold standard, and their real job is calibrating the judges below them. One more split. Reference-based grading needs a known right answer, so it's mostly offline. Reference feed judges intrinsic stuff, groundedness, policy, tone, and that's what lets you grade live traffic. Now, the judge. It's the pattern everyone reaches for, and most people get wrong, because here's the thing. The judge is a model too. It can be confidently wrong. So who tests the tester? You do. My first judge, I got the scale wrong. Binary beats a 1 to 10. Nobody can tell a 3 from a 4, including the model. Pass or fail, plus a written critique. The second thing that bit me, judges have documented biases. Position bias, they favor whichever answer they saw first, so run both orders. Verbosity bias genuinely surprised me. Researchers padded answers with filler, and weaker judges fell for it over 90% of the time. The strongest mostly resisted, but the tendency lives in every model. And self-enhancement, models prefer their own writing. So, 1 dimension per judge, and always give it an I don't know exit. And the third thing, calibration, which is the part I skipped at first. The practitioners who teach this suggest labeling around 100 examples yourself and tuning the judge until it agrees with you. And here's the QA brain upgrade. Don't measure one blended agreement percentage, measure it per class. How often does it catch real failures? How often does it flag good answers? Because a judge that always says pass still hits 90% agreement on a mostly passing dataset and catches nothing. And Hamil Hussein's point, which I love, building the judge, is a trick to make you finally look at your own data. The judge isn't the point, looking at your data is. Keep the judge in mind. In a few minutes, it reads my second brain's answers. Now, let's get specific, because most of you are building on top of a knowledge base. RAG. And there's one rule that has saved me every time. Never grade the whole pipeline at once. Split it in two. Retrieval. Did the right chunk even show up, and how high did it rank? You score this with classic information. Retrieval metrics, hit rate, and MRR, the ranking metric. No LLM call, it runs in seconds. You watched it a few minutes ago. Generation. Given those chunks, was the answer actually grounded and correct? This one needs a judge, and it's where metrics like faithfulness and context recall live. Faithfulness asks one simple thing. How much of the answer actually had backing in the documents it retrieved? Because an answer can be fluent, confident, and still be quietly making things up. So why split? Attribution. A wrong end-to-end answer is ambiguous. Was the right chunk never retrieved, or retrieved and then ignored? Only splitting it tells you which half broke. And in my runs, 9 times out of 10, it's retrieval. You cannot answer a question whose evidence never showed up. Here's the failure mode nobody warned me about. A knowledge base is not set and forget. It grows. And every document you add is a new chance to retrieve the wrong thing. Add a second region's refund policy, and the first one gains a near identical decoy sitting next to it. Add 10 adjacent product pages, and the one you wanted hides under 9 lookalikes. Bigger knowledge base, quietly worse retrieval, and no error anywhere. That's the scary part. The answers still sound confident. So, the experiment. In the repo, I've built 3 versions of the Loomstead knowledge base. Version 1, clean, 28 documents. Version 2, I add the distractors. Decoys engineered to be nasty on purpose. Version 3, piles more noise on top. 228 documents in all. Full disclosure, this is a stress test. I compressed 2 years of organic growth into one commit. And the recipe for every decoy is in the repo, so you can check my work. Same frozen 42, answerable questions. Remember, 8 are traps. If retrieval is diluting, the numbers will say so. Let's find out. Before I run this, my prediction, on the record, the re-ranker survives. The keyword methods don't. Put yours in the comments before you scroll. I'll wait. Okay. Running. Version 1, the clean corpus. Baseline healthy. Now version 2, decoys in. And look at the naive methods first. Plain keyword search and BM25, the lexical stuff most tutorials start with. BM25 just fell off a cliff. 83% hit rate on the clean corpus, 71 on the grown one. That's 1 in 8 answers, gone. 5 of my 42 questions broke on it. Now watch the hybrid pipeline, the one with the re-ranker. On finding the right document, it barely flinches, holds at 93%. This is the re-ranker paying its rent, and today, finally, I have proof. But look at the ranking metric, MRR. Even hybrid slips, 81 down to 74. And here's the tell. It starts handing me the wrong document. Look at this one. I ask, what does the free shipping coupon do? The right answer is the coupon policy. What does it retrieve on the grown corpus? A bug report. An incident about coupon stacking. Same topic, wrong document, and honestly, the answer built on that would sound completely confident. And notice one more thing, the most useful thing. It's version 2, the plausible near misses, that did the damage. Version 3 was pure junk, marketing copy, change logs, and the re-ranker just shrugged it off. Noise is easy. The document that looks almost right is what kills you. That is dilution. Measured. My eyes would never catch it. A frozen set of questions caught it in seconds. Remember that, judge? Time to point it at something real. My own second brain. This is my cross-project knowledge base. The notes my agents actually stand on. And the eval is simple. 12 questions about my own public work, my video tools, my website, my open source. For each one, retrieve the top 5 chunks, answer using only those chunks, and then let the judge grade whether that answer is actually grounded in them. Same judge from earlier, same pass-fail rubric. The healthy numbers first. Retrieval found the right document about 83% of the time, and the judge passed 92% of the answers. Honestly, better than I expected. But keep the setup honest. 1 run, 1 model, 12 questions. Directional, not a benchmark. Then, 1 question. Retrieval just missed. No error. Nothing flagged. The right document simply never came back, and the model answered anyway, confidently, from the docs sitting next door. It told me the reconcile job requires verification, when my own notes said that job was verified end to end. A flat contradiction sitting right inside my own second brain. And that healthy 83% hit rate? It would never have caught this. The judge did. Fail. And that is the whole point. Hit rate tells you what you found. Only grading the answer tells you when your system is confidently wrong. That is the difference between a metric and an eval. So you want this for your own system. Step 1 is not copying my 50 questions, and honestly, it's not picking metrics either. It's reading traces. The experts are unanimous, and it's the step everyone skips. The method comes from the researcher, Shreya Shankar, and it's really just exploratory testing with a fancier name. I took about 100 real runs, and for each one wrote a quick note on the worst thing that went wrong. That's open coding. Then I clustered the notes into a specific failure taxonomy. Date formatting error, not temporal issues. That's axial coding. And I stopped when new traces stopped producing new categories. Why bother? Concentration. In a case study, Haman Hussain published, 3 failure categories explained 60% of all the problems. And one date handling bug, failing 2 of 3 runs, went to 95% after one targeted fix. You won't find that staring at an average. One trap to know. Criteria drift. You need criteria to grade outputs. But grading outputs is how you discover your criteria. So evals are iterative. You're not doing it wrong. That is the method. Once you know your real failure modes, freeze them into a golden data set. 20 to 50 cases, each a real failure, like the day Loomstead invented a refund policy, each with a pass-fail rule so clear, 2 experts would agree. Tier them, easy, hard, adversarial. Balance them, things it should do and things it should refuse. 2 kinds of eval live here. Capability evals start at a low pass rate. Those are hills to climb. Regression evals sit near 100%, tripwires. And when a capability eval passes consistently, it graduates into your regression suite and runs on every commit, forever. And honestly, mine never stops growing. Every interesting production failure becomes a new case. Offline catches what you break, online catches what breaks on you. 2 guardrails before you run off. 1. Hold some questions back, because if you tune your prompts and chunking against the whole set, your system learns the test, not the job. 2. Judges advise. Code gates. Never let an LLM-judge block a build. Deterministic checks gate. Judge metrics inform. And in my own repo, the CI gate is pure retrieval metrics for exactly that reason. And finally, Amel's health check. A suite that passes 100% is measuring too little. Around 70% means it's doing real work. Tools, fast, and the full comparison is in the pinned comment. 3 picks, what I actually reach for. If you live in PyTest, deep eval, it's PyTest for LLMs. If you want config-driven matrices in CI or you're a TypeScript shop, PromptFoo. For rigorous sandboxed agent evals, inspect AI from the UK's AI Security Institute. Around them, Ragas named the RAD vocabulary. Borrow its metrics, implement the 2 you need yourself. Langfuse is the open source self-hosted one I'd reach for when I want tracing and evals in one place. Brain Trust and Langsmith if you'll pay for polish. 2 warnings. As I record this in July 2026, PromptFoo is being acquired by OpenAI, which is winding down its own hosted evals product, and the migration path it recommends is the tool it bought. Keep your eval logic in your own repo and your own CI, and the bigger one, the runner, is the easy part. The transferable skill is designing the dataset and the verifier, which, again, is a testing skill you already have. Retrieval was half the story. The other half, agents that act, call tools, change state. I hold agents to 2 principles. Grade the outcome, not the transcript. What actually changed in the world, not what the agent says it did. And when the path matters, grade the trajectory. Right tools, sane order, no loops. Code-generating agents are the lucky case because execution is the grader. And this one's personal. At work, I have an agent that writes playwright tests in a house style, and honestly, every prompt refinement is a gamble. So it gets a ladder, cheapest gate first. Does the generated test compile? Does it pass our lint rules, the house style mechanized? Does it actually run green? And then the gate that catches the sneaky failure. A test that passes proves nothing. Maybe it asserts nothing. So I take a deliberately broken build and require the generated test to fail on it. If it passes on the broken build too, it's worthless. And here's the bit I love for my testing audience. This is not some 2023 invention. QA has known it for decades. It's mutation testing, born in the 70s. Swebench, the famous coding agent benchmark, is built on the same idea. Your oldest techniques are load-bearing in the newest systems. Only what lint can't see goes to a judge. Binary checklist items. I'm calibrating against my own code reviews. Each task runs 3 times. All 3 must pass, because this agent runs unattended. That's passed to the K. A test that can't catch a bug is not a test. Here's what I believe after all this. Most AI products don't fail because the model is dumb. They fail because nobody can measure whether a change made things better or worse. So every iteration is a guess, and guesses don't compound. Evals turn vibe shipping into engineering. The real skill was never prompting. It's knowing whether your prompt made things better or worse. And if you come from testing, and I did, that's not a new skill. It's your oldest instinct, pointed at a system that thinks. Now the challenge. The repo is in the description. Clone agentic Evals lab, run the dilution script against your knowledge base, and post your numbers in the comments. How many questions broke? I'll feature the worst dilution I get in next week's video. Let's find out whose second brain is quietly lying to them. I shipped a dozen AI systems with 0 evals. Not anymore. Your turn. Subscribe, and I'll see you Friday.